Okay, this is Unit 14, Lesson 2, talking about cone fundamentals, the surface area and volume of a cone. So let's see what we have here. Once again, if you need to possibly have a question that you want answered, then get yourself a piece of paper and a pencil or a pen so that you can write it down and bring it to class with you tomorrow so that we can address it before we go any farther. Okay, so let's take a look at what we have. A cone is simply a 3D solid that has a circular base and a single apex that's also called the vertex. Okay, shown in these drawings is a three-dimensional drawing of a cone and also the drawing of its net. They want you to label the indicated parts and terms associated with the cone, as shown here. So the altitude over here is the height. That's what you need in order to find the volume. The apex is the vertex up here. The base center is essentially the center of the circle that forms the base. The radius is the distance from that center to the edge of the circle. And the slant height are these slanted sides that are going on here. Okay, so these are the labels that need to go with your drawings that are on your notes, and we need to go ahead from there. All right. We have a few more terms that we need to talk about. First one of these is the lateral area of the cone. This is the curved area between the apex and the base, and it's given by this particular formula, which is pi times the radius times the slant height. Okay, the r is the radius of the base, and the little l is the slant height of the cone, which is what goes along the edge. Okay, the total area, this is the sum of the area of the base and the lateral area, and is given by this particular formula, which is the total area is equal to the area of the base, which is pi r squared, since that's a circle, plus the lateral area, which is pi r l that we just talked about in the previous note. And then the volume, where h is the height of the cone, is sometimes it'll be referred to as the altitude, but this is the formula for the volume, which is 1/3 of the area of the base times the height. Okay, example 1. They want us to find the lateral area, total area, and volume of the cone. Okay, so the first thing we need to do is look at the cone and the way it's structured. One of the things, they gave us the height, which is this one right here, and they gave us the 27, which is the radius of the base. We need to find the slant height along the edge so that we'll be ready to find the lateral area. So the first thing we're going to do is we're going to redraw this little right triangle that's formed with the dotted lines inside the cone, and we're going to label it with the corresponding measurements. So 38 is this long leg that's the height going up, and 27 is the short leg that's going across the bottom. Okay, the slant height is the L that's along the hypotenuse. Okay, so the slant height will be given to us by the Pythagorean theorem, which in this case, since we know both of the legs, is going to be the square root of 38 squared plus 27 squared, which evaluates out to the square root of 2,173, which is approximately 46.62. Okay, now we're ready to find the lateral area, which is pi r l. So pi times 27, which is the radius of the base, times the slant height that we just found of 46.62. So this gives us the lateral area is approximately 3,954.45 square meters. Okay, the area of the base is equal to pi r squared, which we know that the radius is 27, so this becomes pi times 27 squared, which evaluates out to 2,290.22. Since we're just using this as an intermediate step, we're not labeling the dimensions on this one. So we want the total area, which is going to be given by the area of the base added to the lateral area, which gives us approximately 6,244.67 square meters. And we got that by taking the 3,954.45 we found in the lateral area and adding the base area of 2,290.22 to it. Okay, so the volume is going to be given by this formula, which is 1/3 of the area of the base times the height. The area of the base was this one we found right here in the middle, which was 2,290.22. So we're going to multiply that times 1/3 times the 38, which gives us approximately 29,009.45 cubic meters. All right, let's take a look at example 2. They want us to find the lateral area, base area, and volume of the cone whose net we see here, which is this. Notice this time they gave us the lateral slant height, and they also gave us the radius of the base. So we need to calculate out what the height of the cone is so that we can be ready to find the volume when we need it. Okay, so the first thing we're going to do is draw a right triangle that represents those particular parts. So 5, which is the slant height, will be the hypotenuse of this right triangle. 2 will be this short base that goes across the bottom that corresponds to the radius, and the height will be the missing leg. So since we know one leg in the hypotenuse, we're simply going to square the hypotenuse and subtract the leg squared from it and take the square root of the result. So this becomes h is equal to the square root of 5 squared minus 2 squared, which gives us the square root of 21, which is approximately 4.58. All right, so the next thing we want to do is get the lateral surface area. So the lateral area is given to us by the formula we talked about earlier, is pi r times the slant height, which is pi times 2 times 5 for this particular cone. So that gives us 10 pi, which is approximately 31.42 square centimeters. Okay, the base area will be given to us by pi r squared. Since we know the radius is 2, that's pi times 2 squared, which gives us 4 pi, which is approximately 12.57 square centimeters. And then we need the volume, which we're going to use this height that we just found over here, the 4.58, and multiply it times the area of the base, which once again is pi times the radius squared, which is what we just found up here. So 12.57 times the 1/3 times 4.58 will give us the volume. So when we put that in the calculator, we come up with the volume's approximately 19.19 cubic centimeters. Okay, example 3. They said if the volume of a cone is 187 cubic meters and the height is 14 meters, they want us to find the radius and the slant height. So this time we're going to be working a little backwards. So here's what we got. We know that the volume is given to us by 1/3 times the area of the base times the height. So we plug in the information we know. We know that 187 is the volume, so we put in 187 for V, 1/3 of the area of the base times 14, because we know the height is 14. Okay, so we're going to divide both sides by 14 and multiply both sides by 3 to take care of the fraction. So this gives us 187 over 14 times 3 is equal to the area of the base. So that gives us 40.07 is equal to the area of the base. And we know the base is a circle, so that means the area of the base is equal to pi r squared. So this means we're going to put the 40.07 in for AB, and we're going to divide both sides by pi, which gives us that r squared is equal to 40.07 divided by pi, which comes out to approximately 12.75. So since this is r squared, we need to take the square root of both sides to find r. So r is approximately 3.57 meters. Okay, so that's the radius. Now we need to find the slant height. Okay, so we know the height is 14. We know the radius is 3.57, so we're going to use a right triangle and find what L squared is, or actually the slant height, which is the hypotenuse. So we're going to use the Pythagorean theorem. L squared is equal to h squared plus r squared. So L is equal to the square root of 14 squared plus 3.57 squared. So L is going to be approximately the square root of 208.74, which is approximately 14.45 meters. Okay, this finishes up lesson 2 for unit 14. So once again, if you've got any questions or if you need to go back and rewatch it so that you can find your question, just go ahead and do so. Bring it to class tomorrow. We'll be glad to address it before we do anything else. Thank you very much. Goodbye.